Okay, everybody, here we go. You can hear chainsaw in the background. Sorry for that, but it's quieter outside than it is inside, trust me. So, section 12.4, we're talking more about logarithms. And basically what happens is there's 3 different rules, and we learn how to use those rules. And the good news is they're not that hard to understand because a log is an inverse of an exponent. So because logs and exponents are inverses, they follow a lot of the same rules. So what this rule tells us is that when we have 2 things here that are multiplied, we can split that up into 2 separate logs that are added. Note that relationship between multiply and add because that's the same as the one for exponents. We add the exponents when we have like bases that are multiplied. When we have like bases in our log, we multiply the exponents. That add and multiply relationship is there. You're going to be expected to go back and forth. This is not a one-way scenario where you're going to have one like this and write it like that. This is one where you might be given either one and you'll be asked to write this one like that and that one like this. We will do examples. All right, the second rule, if you're following along with my exponent references, is so similar to the first rule. So the second rule says that if the 2 things are divided, we can write them with a minus. So I can split this log into 2 separate ones that are subtracted. Or I can take 2 separate logs that are subtracted and combine them into one that is divided, as long as our bases match. So it doesn't matter what they are, but they have to match. The last rule says that if my log has a thing raised to a power, I can drop that power down to the front if I choose to. Or if it makes it easier, if there's a number in the front, I can put it up in the power. Remember, they go both ways. So then I've chosen the hard examples. Most of your problems are actually easier than this, but I chose kind of some of the tricky ones to go through so we'd have a little more practice. And so this first one is similar to, I think, number like 21 in your work. They've given us this long log problem. 1/2 log base a of x plus 3 log base a of y minus 2 log base a of x. What we should notice is that all those bases are the same, so they can be combined into a single log. And that's what we're going to do to simplify, which is pretty much what the instructions are going to say for a big one like this. Sometimes they're going to give you one that's written separate and ask you to write it as a product. That's what they mean. Write it as a product or write it as a quotient. Or they'll tell you to rewrite this in an expanded form or to split it into terms of x and y. So most of your beginning problems are just going to ask you to use one rule real quick one time. This is a longer one where we put a bunch together. So the first thing I did was I combined this and this. So I wrote it as 1/2 of log base a of x minus 2 log base a of x. And I put them together because together they make negative 1/2 log base a of x's. It's kind of like if it said 1/2 of x minus 2 of x, you'd have negative 1/2 x's. So I combined them into one and I left this alone. All right, now same bases added, so that means I can rewrite it as a single log. Sorry, first I moved these up into the exponent. Forgot I did that. So I take this, I move it up into the exponent. I did the same thing here. I moved that 3 up top. And then I just rewrite them. If I scoot this over, I just rewrite them now as a single log, which after this, the simplification part gets a lot easier. I just wrote this as log base a of y to the third over x to the 3/2. Why is it over? Because this was a negative exponent, and that means it goes in the denominator. I really said denominator there, which shows what this is doing to me. So the book wrote it this way in the back. That's why I have my little question mark. Why did they do that? Because they solved it a different way than I did. So they ended up with a slightly different way of writing the answer, but those are equivalent. And that's going to be the trickiest part of these problems for you, is that you might do the same work, get a right answer, and it's hard to recognize that right answer. Sorry. So part of the trickiness of these is recognizing that 2 things are the same. We just want to combine them as much as we can, and then we're finished. Example 2 gets a little simpler. Again, they have the same base, so these are the same. In fact, what I did first was I took my exponent here, that square root of x is an x to the 1/2. So in my head, I called this x to the 1/2, and I did 1/2 times the 2, which gives me 1 log of ax. Then I took these two and I combined them into a single log. Because of that minus, I rewrote it with the division sign. So it says log base a of x squared over x. Argument, argument here, and they're a division problem because of the subtraction sign. And then I know that x squared over x can also be written as just x. So that one simplified a lot quicker. Sometimes one route will do it faster than another route, but there's a lot of different ways to get these problems done. You might not have done what I did first, and you might still have gotten to a perfectly good answer. So it kind of depends. You might have moved that 2 up there and said that log base a of square root of x squared is square root of x. So there's kind of more than one way to arrive at the right answer, which I guess is really good news, I think. So last example that I put on here, it's a little bit of a longer one. 1/2 log base b of x minus 7 log base b of y plus log base b of z. Again, all have the same base, so they can all be combined together. So the first thing I did is move all my exponents up. This 1/2 went up, the 7 went up here. This one didn't have anything to move up, so I left it alone, but I did rearrange them and put the minus at the end. Why? I don't know, because I like to put all my pluses together and all my minuses together, but that's not a rule. So then I took right here, and I was like, all right, well, these two are added, so that means they should be multiplied by each other. X to the 1/2 times z. And this one is subtracted, so it should be divided, so it's on the denominator. So because they have the same base, all three of them, they can all be combined into a single log, which is what I did. Now, it might be rewritten with a square root of x instead of x to the 1/2. It doesn't, neither of these is better than the other one. And sometimes, again, the book is going to have it written a different way than you wrote it, and that's okay. Like, I'm not particular, and again, your test will be multiple choice, so you can't be taken off for that sort of thing. You just have to find the right answer when you see it. All right, this is the trickiest in this chapter, so let me know if you have questions. I'll be glad to answer them. And we'll be meeting live for section 5. We won't have an online or a video lesson. We'll just talk about section 5, so that's a great way to ask questions too. So if you get stuck, hold on to your questions, and when we meet to talk about section 5, you can ask me then.